Today, I'm excited to discuss a physics, two-dimensional kinematics problem. If you're a high school physics enthusiast aiming for MIT, Stanford, an Ivy League university, or preparing for the IIT JEE, then you'll definitely enjoy this video. We'll explore and learn different strategies to tackle this interesting problem. Here we go. A small ball is released from rest at a height h above a smooth inclined plane that makes an angle of 30 degrees with the horizontal. The ball falls freely under gravity and strikes the incline elastically, meaning there's no loss of energy. Assume the incline is long enough for the ball to bounce and strike it a second time. Determine the distance, d, along the incline between the first and second points of impact. Now, I suggest you pause the video and try solving this problem on your own. Once you're done, continue watching to explore different strategies to arrive at the solution. Let's solve this problem in a conventional way, taking the x-axis along the horizontal to the right and the y-axis vertically upward. Before we get into the equations, let's review the diagram. If the inclined plane makes an angle theta with the horizontal, then the path of the freely falling ball will also make an angle theta with the perpendicular line P. When the ball bounces elastically, it will again make the same angle theta with the perpendicular. Let the velocity of the ball just before and after the first elastic collision be v. Its horizontal component will be v sine 2 theta, and its vertical component will be v cos 2 theta. We need to determine the distance d between the 2 points of impact. So the horizontal component of this distance will be d cos theta, and the vertical component will be d sine theta. Now let's review the equations in sequential order. From the principle of conservation of energy, the potential energy of the ball is converted into kinetic energy as it falls. Rho equals half mv square. Rearranging, we get velocity equals square root of 2gh next. Let the time taken between the two collisions be t. The horizontal component of distance, d, is equal to the horizontal component of velocity multiplied by time taken. T substituting theta equals 30 degrees, we get d equals vt. Now, let's apply the kinematics equation in the vertical direction. After substituting theta equals 30 degrees and rearranging the equation, we obtain two possible values of d, because the ball strikes the incline twice, when d equals 0 and when d equals 4h. Hence, the distance between the 2 points of impact is 4h. Now it's time to solve the problem in another way by aligning the x-axis parallel to the inclined plane and the y-axis perpendicular to the plane. Using the kinematics velocity displacement equation, we find that the velocity before and after the first impact is square root of 2gh. Next, by applying the kinematics equation perpendicular to the inclined plane, we can find the time taken by the ball for the first and second impacts, which turns out to be 0 and 2v over g. Then we calculate the distance traveled along the inclined plane using kinematics equation, the time taken values, and we get the distance to be 4h. Wow. This answer matches exactly with our earlier strategy. In fact, we could solve this problem in many different ways by turning the axes at different angles. Now, can we try to solve the same problem in yet another way? Yes, there is an interesting and unique approach using the vector displacement vt in the direction of the initial velocity and half gt square in the direction of gravity. Since the initial velocity, gravity, and the inclined plane intersect at 60 degrees, they form an equilateral triangle, making all three sides equal in magnitude. By equating two sides of the triangle, one after the other, we can find the time taken for the second impact to be 2v over g. Then, using the velocity value from equation 2, we once again find the distance along the plane to be 4h. In fact, this approach is quick and easy. Finally, thank you for watching this video. If you know of another way to solve this problem, please share it in the comment box.